So for slides 18 and 19, I'm just going to give an overview, but not all of the answers. If you go back to the previous slide, this number of moles is what you're going to use to start the problem on the next slide. Just that. In order to convert moles of iron to moles of iron oxide, we need to know the coefficients that go in front of iron and iron oxide. So make sure your equation is balanced. And then you're going to set it up with the moles of the known, which is 0.055 moles of iron equals. You're going to use the coefficient that you see in front of iron here. So I'm going to let you figure that out. And then on the bottom is what we're trying to find. So this would be the moles of iron oxide. It's a little more space. And then on the bottom over here will be the coefficient that you see in front of iron oxide. So when you set this one up, make sure that iron is on the top on both sides. This is the amount from our experiment. This is the amount from our equation. And then on the bottom, this is what we're looking for. And this is our coefficient from our equation from Fe2O3. Once you get an answer here, then you're going to go on to slide 19. You're going to paste the moles that you calculated on the previous slide. Should be a number. And you are going to determine the mass of iron oxide. For that, you will need the molar mass of iron oxide. So to find the molar mass of iron oxide, you're going to multiply the mass of iron from the periodic table by 2, because there's 2 atoms of iron in this formula. And then you're going to add 3 times the mass of oxygen from the periodic table. And I'll let you go ahead and find that one. And then the total would be the molar mass of iron oxide. When you set it up, you're going to include the thing that you know, which will be the moles of unknown. And we're actually looking for the mass in this case. So on the top, I'm just going to put mass of Fe2O3, because that's what we're looking for, is going to equal the molar mass of Fe2O3 over the moles, which we would know from our previous slide, over 1 mole in this case. So for this problem, in order to solve it, you will need the moles from the previous slide, which I'm just putting N mole for now, but you're going to calculate that on the previous slide, and the molar mass of Fe2O3. Then you're going to multiply across, and you're going to set that equal to 1 times the mass of Fe2O3, which is what we're looking for. And that should give you your answer, because 1 times the variable is the same. Good luck. Let me know if you're having any trouble.